Hi there and welcome. I'm Andrea Rapuzzi and I present you a CNN solution for building detection using SIR imagery. Today we're going to present the winning solution to a recent ESA challenge for UNOSAT. What is UNOSAT? UNOSAT is a United Nations institution that provides satellite imagery analysis for humanitarian purposes. The challenge, called AI for Rio Challenge, is aimed at detecting building footprints in Iraq. This in order to support the local government to plan reconstruction and development activities in the area. Our team included both people with a strong domain knowledge in remote sensing, as well as experts in machine learning and deep learning. The challenge mainly was divided in two phases. What we are going to present today is the solution to phase 1, which is a semantic segmentation problem with two classes, the building class and the background class. What about the data? We had SAR images, quite big, 10K for 10K pixels, with dual polarization, VH and VV, and multi-temporal acquisitions. The training set contained labeled data from 4 Iraqi cities, and the test set contained unlabeled data from other 4 Iraqi cities. SAR images, compared to the optical one, can benefit from active illumination, so you can do day and night acquisition, and they are quite weather insensitive. On the other side, image intensity for objects like building can be heavily orientation dependent, so it could be quite tricky to correctly segment them. This is a big one to do in 1 minute. Our solution had 3 modules. The first, the preprocessing, was in charge of extracting features. By feature, we mean pixel feature, so each feature is actually a new image. It could be temporal aggregation, an image transformation, interaction between the polarization, and so on. The output of this module is an image with many channels, 10, 20, one channel for any feature. The second module is the tiling module, which allows us to generate image tiles on the fly, and it's used at training time to randomly generate tiles to provide a natural data augmentation, and at inference time as a deterministic and overlapping tile generation to provide for TTA. The third module is the model itself. It is composed by 2 submodels, which we trained end-to-end. The first is a channels encoder, which is a small CNN with few layers, 3 to 5, and very small kernel size, always 1, sometimes for the first layer, size 3. It is used to find an optimal 3 channels representation for the 20 channels input. The second submodule is a UNet, which is a classical segmentation architecture, which we customized with a ResNet backbone. We also customized the skip connection. We used summation instead of concatenation for the horizontal skip connections. This provided us with regularization, but more than all, it dramatically reduced the training time. As you can see from this picture, our solution is capable of producing a very good segmentation, both for large and dense areas like Baghdad depicted here, but also for small villages. And it's capable of distinguishing and correctly classifying buildings with very different backscattering values. The model F1 score, calculated on a 4-4 cross-validation, is around 0.75. And that's it. If you have any more questions, please feel free to ask me. You can also reach me later at my email address, andrea.rapuzzi@a-sign.it. Thank you for your time.